Hey guys, this is Christian, and in today's video I'm gonna show you how I upgraded my Docker containers to the next level using Docker Swarm, or more precisely, the Docker Swarm mode. Because some people say that if you want to have container orchestration, you should not really care about Docker Swarm because it's dead. And that was also part of the reason why I never really used it in my home lab. However, you should not confuse the Docker Swarm mode with the Docker Classic Swarm project, which is indeed not actively developed anymore. The Docker Swarm mode is something different, and it's directly integrated into the Docker engine and allows us to create and manage a cluster of Docker nodes, orchestrate containers with fault tolerance, load balancing, and rolling updates, and also some other cool features for credential and config management. And it's really damn simple. Once I started looking into it, I realized this is maybe the perfect middle ground for people that want to have something more sophisticated as the simple Docker engine, but not as heavily complex and overwhelming as Kubernetes. And if you're one of these guys, you should definitely keep watching this video. And by the way, while you're learning the new Docker Swarm mode, you should also check out my new favorite tool, Recall, the sponsor of today's video. Because Recall is an AI-powered knowledge base that helps you learn faster and retain more. It is super simple to use. You just install the Chrome browser extension, and while you're reading a page, for example, the Docker's documentation, Recall can create a quick or detailed summary of that entire page with all the critical information and store it in your personal knowledge base, where you can further organize everything or take additional notes yourself. The cool thing is that it doesn't just work for pages. You can also add podcasts, PDFs, articles, blogs, your existing bookmarks, markdown notes, or even better, my YouTube videos. Then you automatically can keep track of everything you're learning here. And what is super cool, Recall automatically creates connections between the different elements that you can even see in their brand new augmented browsing feature. Like, for example, when I'm reading the Swarm mode documentation here, which mentions Kubernetes, it automatically links back to my Kubernetes page in the knowledge base. Then you can create a comprehensive collection of what you actually care about, and you can even use the new AI-powered chat feature in Recall to ask questions, get more information, compare things, or even generate examples from all the stuff that you have collected, including all of your notes, videos, and so much more. I think it is absolutely fantastic, and the best, when you sign up before the 1st of October with my code LEMPA25, you can get 25% off a Recall subscription. So definitely check that out now. Of course, you will find the link to Recall in the description down below. Alright guys, so now let's jump into the Docker Swarm mode. Before I show you how to install and set it up, and by the way, this is super damn simple, let's learn a bit more about the different features and capabilities. So the Docker Swarm mode transforms all your separate Docker engines into a single virtual Docker host, and that gives you a centralized and unified cluster of the different Docker engines called nodes in the Swarm mode, and provides built-in feature discovery with automatic DNS assignment for services and internal load balancing, so you can easily distribute incoming requests to your containers evenly across all the different nodes. And that, of course, gives you fault tolerance and high availability. The Swarm mode also has a scheduler that automatically restarts failed tasks on healthy nodes and ensures your applications and containers are always running. And it also has some interesting security capabilities, like there is a secure node-to-node communication with mutual TLS encryption, and it provides an integrated secrets management to safely handle sensitive information like passwords or API keys. I will later show you how that actually works. And it does things like rolling updates and rollbacks, so you can easily revert back to an older version of a container configuration. And the scheduler is intelligent enough that it places containers based on resource availability in the cluster, like CPU and memory. And you can even configure so-called constraints, optimizing cluster resources, and there are many, many cool things here. People that already worked with Kubernetes like me, the first question that I had is, why the heck should I care about Docker Swarm when I have Kubernetes? And sure, Kubernetes is kind of like the more sophisticated solution that even has some other interesting capabilities going beyond the feature set of the Swarm mode. However, if you once tried out Kubernetes, you probably will agree that it has a kind of steep learning curve. And trust me guys, the Docker Swarm mode is just so much easier to set up, and I think even easier to use, because you can use some tools that you already know. That is not really the case for Kubernetes, where you need to learn a completely new technology. So I hope I got you hooked and you want to learn more about the Swarm mode, so let me show you how to easily set up this. And first of all, I want to prepare 3 new virtual machines where we install the Docker engine. For this, I'm going to use my new Python scripts that I recently developed using AI. So I'm going to create 3 new virtual machines. I'm just going to call them VM tests. And I'm pretty sure while you're watching this script now, you definitely want to check that out. So don't worry, I'm going to make a video about it. I just need to polish a few things and then I'm going to share my GitHub repository for these scripts that I've created. So this way I can just distribute new virtual machines for demonstration videos like this in a few seconds using Cloud Init and the Proxmox templates. Alright, so now the creation of the VMs is complete. They should already contain the Docker engine. By the way, if you don't know how to install the Docker engine on a Linux machine, then you should definitely check out my Docker tutorial videos. So there I explain everything, and you probably already know it from my other videos, so I'm not gonna spend too much time on this. Now, if we want to create a Docker Swarm cluster, I need to start with one machine that will become the new leader of this cluster. Ideally, this is the first virtual machine, so I'm just gonna open a new SSH connection to this IP address and verify that we can execute the Docker commands. So now we can create a new cluster with the Docker Swarm init command and also add the flag advertise IP address where the other Swarm nodes will try to connect to. In my case, it's the 10.2030.1, the IP address of the first node. And that's it. Now it is technically a Swarm cluster already, and it generated a new join token with a command that you just need to copy and execute on the other 2 nodes as well. So let's open a new connection to the VM test 2. And then just paste this command, and now this node has joined the Swarm as a worker node. So what that means, I will cover in a second. Let me just finish the third node. And now we can go back to the leader and execute the Docker node ls. So that should give us all the Docker Swarm nodes. As you can see here, we have VM test 1, 2, and 3. But as you might have noticed, only the first node is a leader. And when you try to execute the Docker node ls command on the second server, for example, you will get the error message, this node is not a Swarm manager worker nodes. So that is probably a concept that I have to explain because it's really important for high availability later. Technically, you can just run this cluster with one leader and add as many nodes as you want as workers. If you don't have 3 Docker nodes, in my home lab, for example, I'm running this cluster with just 1 leader and 1 worker, so 2 machines, but it will not have fault tolerance because if the leader goes down and you only have workers in the cluster, the Docker Swarm cluster will not be functional. So it requires an odd number of leaders, and more than half of the leaders have to be online that the Swarm cluster is functional. It's kind of similar to Kubernetes. There's also the same. So you can't have 2 leaders, you need at least 3 to achieve high availability and fault tolerance, or you accept that if the first node goes down, everything is not working anymore. So you can really decide how you want to set it up. But I would recommend you to run a Docker Swarm mode with at least 3 nodes, where you promote the 2 worker nodes as additional leaders as well. The way how you do this is you need to do it from the leader. So just run docker node promote and then VM test 2 and VM test 3. When you now execute the Docker node ls, you can see that the 2 nodes have the manager status reachable. So the first one is still the leader, but if that one goes down, one of the other nodes will become the new leader. And now, once you promoted the other nodes, you can now execute the Docker node ls commands from all the other leaders as well. Alright, so that's how you set up the cluster. It's super damn simple. Now let's start creating a Docker service, because Docker services are kind of different from Docker containers. The Docker containers, these are the standalone versions that you can just run on the Docker engine. But when you enable the Swarm mode, you probably want to create these Docker containers as Docker services, because Docker services can have more than one container running on the same cluster. So if you define that a Docker service has 2 replicas, it will make sure that at least 2 containers with that service are running on the entire cluster, and it automatically tries to find out where is the best node that has some resources left to run and start up some required instances. So you can easily do this with the Docker service command and then just create a new service. For example, let's create a new Nginx server. I always use the Nginx image because then I can easily demonstrate later how the traffic distribution is working. So let's create Nginx server 1. I will publish the port 8001. So there I will reach my new web server, and I want to have 2 replicas in the Docker Swarm cluster. Of course, I also need to define the image Nginx. Just use the latest tag. I think that's fine. And now you see that it's starting up 2 containers. It's preparing these 2. So it first of all needs to pull down the image. And let's see where the Docker Swarm mod distributes these containers on. At this point, you don't really know because it's dynamically scheduling these containers. All right, so now it waits a few seconds to verify that the tasks are available. And yes, so now it's complete. All right, so let me show you what happens when you enter Docker service ls. That will list all the services on the entire Swarm cluster that you have created. Here an Nginx server with the mode replicated that has 2 replicas. And if you want to know where exactly these containers are running on, you need to use the Docker service ps command, and then you need to use the name of the service. And then you can see, oh, there are 2 containers running, Nginx server 1.1 and .2. The first container is running on the secondary node, and the second container is running on the first node. Yeah. So it's kind of the other way around. And if you execute the docker ps command to show all the Docker containers running on that Docker host, you only see the container that is running on that particular node you're executing this command, because again, the docker ps command is a Docker standalone command, not a Docker Swarm command. So you only see the containers distributed to that Docker engine here. But you see, there is the container with a unique identifier that identifies that particular part of the Docker service here. If we would execute the docker ps command on the secondary node, you would see the other container, and on the third node, there shouldn't be any container running, as you can see here. Okay, that's how you operate and manage these containers. By the way, if we would stop this container, for example, let's also try this. It always makes sure that there are 2 replicas running on the Swarm cluster. So here you can also see a history of all the replaced containers. Let's, for example, execute docker service help. So here you will see what commands you all have. You can inspect logs, you can inspect the service details. You can even roll back to previous versions that you see in the history, or you can scale, so increase or decrease the number of replicas of that service. And you can also update your service. So if you have a new image version, for example, Docker service update, and let's say image Nginx not latest, but 1.2.9.1. So then it's automatically changing the configuration, making that active on all the nodes. So it needs to restart both containers. So if we ps that, so here you can also see, it already stopped or shut down the old containers with the latest image configuration and started up 2 new ones on the VM test 1 and VM test 2. And to just show you how the rollback works, let's also do that. Now we are just rolling back to the old configuration. And you can see that we are running the containers now with the old configuration, so the latest image. So that's really great if you're making updates and you want to change things. Some stuff didn't work and you need to revert it and stuff like that. So it's really useful. By the way, this history that remains until the Docker Swarm mode from time to time removes old entries from the history. So if you see these old containers, don't worry about it. They will be auto-deleted after some time. I don't really know the timeout, but yeah, at some point it will just get rid of it. All right, so now let's take a look how to get access to this Nginx server. I think this is also super damn easy because, as I can see here, it's currently running on the VM test 2, VM test 1. Now, the VM test 3 doesn't have the Nginx server up and running, but we can still send a simple web request to the IP address of the third node. Now, we even get back a response, although the container is actually not running on the third node, but because it has an internal load balancer, Docker Swarm will automatically distribute the traffic to any container that's running on the cluster. And it doesn't really make any difference to which IP address you send the traffic to. I could pick the first server, the second one. it will automatically distribute that request to the running containers on the nodes. The fact that this is built in is super amazing, and I think makes it so much easier than having to use any complicated load balancer configuration in Kubernetes like MetalLB or KubeVip. So that is really, really powerful. But wait, it gets even better because the Docker Swarm mode also supports Docker Compose. And I think this is such a big plus in the Swarm mode compared to Kubernetes because I like Compose files. This is where I have all my deployment templates stored in. And it is super easy to deploy Docker containers using a simple Compose file. However, the Compose file format on Docker Swarm is slightly different than using Docker Compose files on standalone Docker engines. So let me open a connection to the first node and let me create a new project directory that I just call nginx. And here we're gonna create a new compose.yaml file. All right, so I'm gonna pick a template from my boilerplates. By the way, you will find this on GitHub. So we're gonna modify a few things here because we don't need all of it, but I think the ports we definitely need. So our service that we have created has the 8081, so I'm gonna just increase the number here. The volumes we don't need for now, and the network we also don't need. Obviously the traffic labels I'm also gonna remove. That's what a simple Docker Compose file for standalone Docker engine would look like. And now we need to get rid of a few things. First of all, the Docker Swarm mode doesn't support setting container names because that's done dynamically. So you need to get rid of this, uncomment it or remove it, whatever. And the restart policy as well. So that also doesn't work because Docker Swarm has its own restarting logic with a scheduler. As I said, when a Docker container is deleted, it automatically makes sure that it's restarted to always have the number of replicas that you have defined. By the way, replicas, we need to define that somewhere here in the compose file for Docker Swarm. So I usually do this under the image and we need to use deploy. So you can see GitHub Copilot is nice enough to create this template for me. So here we can define the replicas and we can also define some constraints. Just look at the documentation, what is possible, but you can say that this container should only run on a role, for example, manager. Or you can also say that it is on the node with the host name VM test 3, for example. You could also say that, for example, you want every host names and exclude a specific host name, for example, VM test 1. I want to run them on VM 2 and 3. And now the command to deploy is not Docker Compose up, so that would start it in standalone mode. If we want to start a Compose file as a Swarm service, we have to use the Docker stack command. That will deploy a new stack using a Compose file. And we need to say stack deploy Compose file, or just shortly -c. The compose file, and then the name of the service. In our case, we want to call this nginx server 2. Okay, so now when we start deploying this, the stack contains 3 containers. As I defined in the constraints, they are not started on the first node, but 2 on the third node and 1 on the second node. So I think this is absolutely fantastic. And by the way, what is even better, when you enable the Docker Swarm mode on a server that has the Docker engine and already deployed containers or Docker Compose stacks with Docker Compose in standalone mode, those existing projects will not automatically become Swarm services or being part of a cluster. You have to start them as services or start them as stacks manually. This is really powerful because I'm running, I think, like 30 different Compose projects in my home lab. And if I imagine I would have to migrate them all to Docker services, that would be a lot of work. But because you can run them side by side, I have activated Docker Swarm mode on my home lab server, but I'm still running some standalone containers. And I'm from time to time migrating the one or another service to Swarm stacks, and I can do this in my own pace, so I'm not really rushed by anything. I can run them side by side. So these are all of the great things about Docker Swarm mode. I absolutely love it. However, there are also a few challenges that come with that, of course. You're using volumes in Swarm mode. These volumes are local to each node by default, so they are not automatically shared across the cluster like the configuration, which means if a task that is running on the first node has a volume and then it needs to shut down and start up on the second node, the data is not the same. The good news is that Swarm supports storage drivers. By the way, I've recently done a video about Docker volumes using NFS. That is a solution that you could use to store the data outside of your Docker Swarm cluster or your Docker services. Run this on a separate NAS device, mount the volumes using NFS. This way, you could have scaled services or scaled stacks across different nodes by still having a persistent shared storage. This is also possible. However, I know that NFS is not really the best technology when it comes to that. It's also not the most performant, and you might run into some issues with databases and so on. I personally never had issues, but people have been telling me that this is not a good solution. So maybe there is a better way of handling this, but I will look into this. I will take a look at storage drivers, and I wanted to do this anyway for other topics, so I might just experiment with Ceph or other distributed storage systems. We will see. But for now, I'm using constraints and slowly start migrating some of my containers to Docker stacks or Swarm services. But yeah, Docker volumes is definitely an area that you should carefully look at. However, Docker Swarm mode also has some other interesting capabilities when it comes to networking or credentials and config management, and I want to talk about these things as well. First of all, let's take a look at the overlay network driver. So this is by far one of the most interesting features for me, because the overlay network driver allows us to create a Docker network among all the Docker Swarm modes. And overlay networks, this is often used to create a connection between the Swarm services, but you can also use it to connect standalone containers running on different hosts. And by the way, what is pretty cool, an overlay network by default is actually made for Swarm services and Swarm stacks, but you can still connect Docker standalone containers, have these containers or standalone projects communicate with a Swarm service. So that's pretty cool. Let's also take a look how to do this. Actually pretty simple. You just need to execute docker network create and then make sure that it has the driver overlay and that you add the attachable flag. So only when you enable attachable for this Docker network, standalone containers managed in Docker Compose projects can be attached to this overlay network. Otherwise it won't work. And you can, by the way, also add an encryption with opt encrypted. However, this encryption uses IPsec. It will have a performance impact. So don't use this for any performance-heavy critical services like database operations over the network or whatever. And then you need to define a name for the network. For example, let's create the network with the name proxy. So then we can list all the networks. You can see that the Docker stack also created a default network with the type overlay, and Docker Swarm also created a default ingress network. However, this is not attachable, so that's why I think it is good to create a custom one that you manage externally. And then in your compose files, you can of course say networks, can say proxy, this is external true, and then define that this container, for example, is connected to the proxy network. So the overlay network driver is really a big plus for Swarm mode, but Swarm mode also introduces two other superpowers that I want to show you called secrets and configs, making credential and config files super safe and simply distributed across your cluster. Because the problem with standalone containers in Docker is that we commonly store sensitive credentials or data or also config files directly in either the compose stack or using environment variables using .env files that are stored in projects on the Docker host. And in a cluster, it is much better to manage these things centrally And the Docker Swarm mode has the feature to do that internally in its encrypted database that is shared across the different nodes. So you can centrally manage credentials and configs and transmit them to only those containers that need to have access to it. And this is really great for storing API tokens or SSH keys, certificates, and other things that are sensitive. Let me show you how to do that. So you easily just create a secret, something like super safe secret, and pipe this to the Docker secret create command. Now you need to give it a name. For example, secret one. I'm not really creative, as you might know. And also list all the secrets that you have created. And then if we go back to our compose file, we can use this secret when we append the secret section here. Okay, it's not the nginx config, it's secret 1. This is managed externally. You could also manage secrets or configs directly in the compose file, but I'm not really a friend of it. I think it is better and more safe to create them manually using the shell and then just include them to your project as externally managed. And now here we need to add the secret section. So you might wonder where these secrets are actually located inside the container. Now Docker uses a file that is created in the /run/secrets directory. And this you could also access, for example, if you have environment variables, something like API token file, then you can use this location here, run secrets1, and this file will contain the actual secret that is stored in this object inside the cluster. One problem I ran into, especially with some services that accept only string variables in their environment variables. This is a problem because this file contains the secret, but it's not loaded automatically in the environment variable. So you can't do it this way. You have to use container images that support reading secrets from a file. So you can't do it like this. You can't define the token and using this here. Then it would just contain this string. So you have to specifically make sure that the container supports loading these tokens or secrets from a file that you can define in the environment variable. So this is a challenge that I'm also running in when using traffic or migrating traffic to Docker Swarm, but I will cover this in my traffic video. It's actually not a big deal, but you need to be aware of this small problem. And the next thing is that you can also add config files that you manage in Docker Swarm and also import it to the Docker services. So assume we would have a configuration file in here that we want to pass to the individual containers. So we first of all need to create that config with docker config create, and we just say this nginx config. Yeah, nginx config file. Let's name it this way. And then we can say our config.yaml file. So now it's generating a config file object from that file. Now, the only problem is that you can't really edit these configs later. You can list them just like the secrets, but if you want to change them, there is no edit command, so you would have to remove them and recreate them with updated values. That's the only downside of this. But you can do it the same way, just like with the secrets, when you go back to the compose file and say configs nginx config file and make this external true. All right. And then inside the container, we need to add configs. And now we can define the source is the nginx config file, our object. And now we can say where we want to put this in. Yeah, I don't know if that example config is actually a valid one. I don't think so. But anyways, let's nginx example conf example YAML. Yeah, I think that will be safer. Okay, all right. So let's redeploy this project and see what's happening inside the container. I think it should be this one here, updating service. All right, yeah, perfect. And then we can go to the second or third node, depending on where any of the containers is running. It doesn't really make any difference which containers we choose, but if we want to open a shell inside this container, for example, first of all, check the secrets folder. There's our secret one. So if we just cut the output of that, we have our super safe secret here. And if we go to etc nginx, we should have our nginx example config file with all the values that we passed as an object. And all the other containers on the cluster, no matter on which node they're started, will have the same config file and the same secret as all the other containers. So I think that's pretty cool. And yeah, so that's the Docker Swarm mode. Obviously, you can do so much more with this. And of course, I need to make some follow-up videos explaining how to migrate several services like traffic. I already talked about this, but there may be other suggestions you might have about Docker Swarm. And please, I want to know, what are your thoughts about it? Do you like Docker Swarm? Will you use it? Again, you can just enable this on your existing Docker hosts. All your existing projects will still run in the same way, so it's not damaging or hurting you. But you can enable it, form a cluster, and then start experimenting with it, and from time to time start migrating the one or another container project to Docker services or Docker stacks with Compose. I think it's a pretty cool technology, and I will definitely continue using it. But yeah, I think that's it for today. As always, thank you so much for watching. A big thanks goes out to all of my supporters and members of my channel. You guys are really amazing. And have a nice day, everybody. I'm gonna catch you in the next video. Take care. Bye-bye.